All right, well, this one looks ugly. We got this messy thing on the left-hand side, and supposedly we're supposed to prove that that's equal to 2 secant of x. Now, this one is already, on the left-hand side, it's already written in terms of sine and cosine, so there's nothing I can really do to change any of the trig functions to sine and cosine because they're already in sine, as written as sine and cosine. But I think I'm going to work on the left-hand side because that definitely looks most complicated. I don't really know where to go with secant. I mean, I could turn secant into 1 over cosine, but I don't know. I wouldn't know where to go from there. So let's work on the more complicated side. And I see I have this sum, and I have 2 fractions. Another thing I could do, it's often a good strategy, is to try to combine those fractions into 1. But I would need a common denominator, which would mean I'd have to multiply the first one by cosine over cosine, and the other one by 1 plus sine over 1 plus sine. And I'm looking at thinking like, I don't know. That just doesn't seem like it's going to do what I want it to do. So, like I said, these things take a little practice because one of the things that you should always remember is the Pythagorean identity: sine squared of x plus cosine squared of x equals 1. So I'm just going to write a little remember. So this is just sort of a pro tip. Remember. So I know that. Now, and I also know that I can rearrange this. Cosine squared of x is equal to 1 minus sine squared of x. Now, you might be wondering, well, I have 1 plus sine of x, and it's not even squared, and it's a plus. But here's another thing. This right here, this thing right here, is a difference of 2 squares. So this is a difference of 2 squares. And we know how to factor it. What does it factor into? The difference of 2 squares. So I can factor this into 1 plus sine of x times 1 minus sine of x. And it's often times when you see a 1 plus sine of x or a 1 minus sine of x, sometimes it's a good idea to sort of complete the square or to turn it into 1 minus sine squared of x. Okay, so so I know that cosine squared of x is equal to 1 plus sine of x times 1 minus sine of x. All right. Now I know you're thinking, how would I know that? Why would I think to use that? So let me show you an approach to this problem. Now I'm seeing the 1 plus sine of x here in the denominator, right? So what I'm going to do is I'm going to take that first fraction. I'm going to multiply by 1 minus sine of x over 1 minus sine of x, right? I'm going to take that times the cosine of x over 1 plus the sine of x, okay? Now I still have over here the 1 plus sine of x over cosine of x. And I'm trying to prove, does that equal 2 secant of x? Okay. Now when I do that, I multiply the numerators, multiply the denominators. What I end up with is, I'm going to distribute, right? I'm taking basically this whole thing, I'm going to distribute the cosine through the parentheses. So I end up with cosine of x minus sine of x, cosine of x, all over 1 minus sine squared of x. Okay? And over here, I've just got 1 plus sine of x over cosine of x. Okay? And I'm asking, is that equal to 2 secant of x? All right, well, the nice thing here, though, is that this 1 minus sine x turns into cosine of x. Oops, I forgot my x here. And I have a cosine in the denominator here, so I could multiply this whole thing by cosine of x over cosine of x, and then I'd have a common denominator of cosine squared, right? So this becomes, let me write this out here. I got cosine of x minus sine of x cosine of x. I can write this as all over cosine squared of x. And this becomes, now if I distribute the cosine, okay, I'm going to get cosine of x plus sine of x cosine of x all over cosine squared of x. Okay, is that equal to secant of x? I'm running out of room here. Okay, so now I have a common denominator, and you can see when I add the numerators, when I have a common denominator, I just add the numerators. So I have a minus sine of x cosine of x and a positive sine of x cosine of x. So what I end up with is 2 cosine of x over cosine squared of x. And is that equal to secant, 2 secant of x. Okay, so I have a cosine in the numerator, and I have a cosine times cosine in the denominator, so I can cancel out one of those cosines in the denominator. Basically what I have is 1 over cosine. I'm running out of room, but I have 2 over cosine of x. Is that equal to 2 secant of x? And 1 over cosine is secant, so this becomes 2 secant of x is equal to 2 secant of x. So let me scroll down so I can write my final QED. All right, that's about as tricky as they come. So, but go ahead and look at the next example. It's a little bit, it's kind of similar, but you might try it on your own before you watch the video. And notice that we have a 1 plus cosine. All right, I can rearrange that Pythagorean identity in terms of sine too, and get sine squared is equal to 1 minus cosine, which is also a difference of 2 squares. So I'll meet you in the next video.